we know that matter is made up of atoms, or let's put this word here, elements, okay? And those atoms or elements combine to make what we call compounds in chemistry. And compounds in geology are the things that we call minerals, right? So minerals are the basic building blocks of earth materials, right? And the white sheet will tell you how to identify minerals if you haven't done this before. And sort of the first thing you have to do, the first subdivision when you identify minerals is you ask the question, do they look shiny like a piece of chrome, something shiny and metallic? And if so, the mineral is called a metallic mineral. And then we basically subdivide the metallic minerals, the shiny minerals. And I don't mean shiny like glass, I mean shiny like metal, right? And then we basically subdivide the metallic minerals by a number of other physical properties, which I'll talk about in just a second. Or we have non-metallic minerals. So I'll say this one shines like metal. Okay? Non-metallic minerals can be shiny, but they typically shine like glass, not like metal, right? So these can shine like glass, or they can be dull. So that's the first thing we have to do when we identify minerals. We have to ask, are they metallic or non-metallic? Okay? And then we use a whole bunch of other physical properties to identify the minerals. Hardness is an important one. A piece of glass has a hardness of about 6 or 7. So there are pieces of glass in the hardness kit. So glass is the hardest thing we've got. Nail is pretty hard. I mean, a metal nail here. Let's see, a copper penny is the next hardest. That's about a hardness of 3. So I'll put some numbers here, 6 or 7. This is about a hardness of 3. Finally, your fingernail is really soft. That's a hardness of about 1 or 2. Okay? So we use hardness. We use something called streak. And you'll see there are these white ceramic plates in the test kits, and you run the mineral against that white ceramic plate, and you look for the color that it leaves behind. That's the streak. And finally, the other important one is something called cleavage. Basically how the mineral breaks along planes of atomic weakness. Okay, you had a question? Scratch plates, yeah, exactly. Okay? All of this stuff is sort of laid out on this identification chart for you. But the first thing you have to do is ask, is the mineral metallic or non-metallic, right? Because the charts are organized for metallic versus non-metallic minerals. The standards that you're working for talk about different mineral groups. And basically, minerals are grouped based on their chemistry. So once you're able to identify minerals, you can think about different mineral groups. The most common rock-forming minerals are called silicate minerals. We have oxide minerals. We have carbonate minerals. All of those things you ought to be able to tell from the chemistries what mineral group the minerals are in. Okay? And that's one of the blanks on the pink sheet, chemistry. So you can write down the chemistry today, and then you can go home and study those and put them into mineral groups based on their chemistries. Okay? So minerals, the building blocks of earth materials, and then when minerals get together and they make sort of larger objects, what do we call those larger pieces of earth material? What do we call aggregates of minerals? Rocks, okay? So the next step up are rocks. These are just aggregates of minerals. Okay, and kind of three major classifications based on how rocks form, but there are some overlaps between these classifications. So although you might feel like an expert after you can do all of these rocks in our test kits, the Earth has always got surprises for us. And these three classifications have some slight overlaps to them. Okay? But the three major classifications are, you guys know this, right? Igneous, sedimentary, and metamorphic, right? So if you don't know much about these three rock types, you can simply go to the tubs and grab a tub of igneous rocks, and using the charts, you can start to learn about the igneous rocks, right? Using the tub, you can start to learn about the metamorphic rocks and the sedimentary rocks. So I'll tell you how igneous rocks are classified according to this chart. Can we see the mineral grains or not? So the first classification of igneous rocks is based on whether we can see mineral grains with our eye or with a hand lens. Mineral, that's a major rock-forming mineral. Those are really important earth materials. And what is it about igneous rocks? How do they form? Why do we separate them from the other rock types? Right. So they're made out of rocks that initially start out being liquids, and they come up to the surface or near the surface, or sometimes deep within the earth. They cool and they crystallize, and they make a rock that looks sort of like a snow cone. If they crystallize really slowly, we call those intrusive igneous rocks. And if they come up to the surface, they make things like lavas, pyroclastic flows, all different kinds of styles of eruption of igneous rocks, right? It gives us different type of volcanic rocks. Okay? So that's basically what you do here. Can you see the mineral grains? Can you not see them? Are they mixed? You can see some, but you can't see others. Is the rock glassy? Is it frothy? Is it vesicular? So how do you think frothy and vesicular igneous rocks form? How does the gas escape from a liquid? At the surface or within the earth? At the surface. So all of those rocks on the bottom are basically volcanic igneous rocks, right? The frothy, vesicular, and glassy ones. Vesicular means that they have sort of trapped bubbles in them. And frothy means it looks like the top of your dad's beard. Really fine bubbles. Vesicular means it's got bigger bubbles. Okay? Sedimentary rocks are rocks that are deposited at the Earth's surface. So only at the surface, not in the Earth anymore. And sedimentary rocks are sort of pieces of sediment that either are deposited by wind, water, or ice, right? And we have kind of three separate subclassifications of sedimentary rocks, what we call detrital. Does anyone know what the word detritus means? There's another one called chemical or biochemical or organic. So either the rock is detrital or it's chemical, biochemical, or organic. So what does detritus mean? It's sort of like bits and pieces, right? Like sand at the beach is detritus. The stuff your mom sweeps up off the floor is detritus. It's small particles. that get sort of washed in by wind or water and cemented together to make a rock. So pieces.
Is that sometimes called plastic?
Yeah, these could be called clastic also. Okay? And chemical rocks would look like sort of really sparkly and crystalline, and organic rocks you're going to see evidence for former living organisms, maybe plants, maybe animals. Okay? So if you don't know much about sedimentary rocks, probably the smartest thing you can do is take the pink sheet, go to the sedimentary rocks, get a box, and just start teaching yourself about them. Identify, use the names that I've given you, and get familiar with the different types of sedimentary rocks. Maybe the most surprising thing will be there's about 3 or 4 different types of limestones in that kit. So again, the Earth has a lot of varieties of these rock types, and you might feel like an expert when you do this, but we're always surprised when we go out in the field and study geology in real life. We always learn new things. Okay? Finally, metamorphic rocks. How do metamorphic rocks form? These are probably the least understood rocks in the world. Why and how do they form?
They're the other types of rocks that have morphed somehow.
Yep. They're the other types of rocks that have somehow changed chemically and changed shape. So metamorphic rocks are the least understood because they form deep within the Earth's crust, and we can't go down there and watch them form. We can only see them when they're brought to the surface, right? So we don't understand metamorphic processes as well as we understand sedimentary processes or volcanic processes. And basically, for your rock identification stuff today, we're going to identify metamorphic rocks based on the fact that they have metamorphic layering. So this is not the same as sedimentary layering. These are rocks that are layered with new metamorphic minerals that grew deep in the earth. Okay? And how you tell a metamorphic rock and metamorphic layering is it's really shiny. The metamorphic minerals tend to be really shiny and sparkly. So look for those kind of mineral grains on the layering surfaces. So either they have metamorphic layering or they're what's called granular. They don't have metamorphic layering at the scale that you can see. Okay? So I've taken like